I'm going to start off with the review, and actually Alex is going to help me out with, there you go. Alex is going to help me out with the writing of everything so that I can do the explaining, and she'll be doing the writing for me. Select the pen at the bottom. Oh, there you go, because you're using the black. Don't use the black. But if you want black color, you have to select it from here. Okay, go ahead and start. Okay, on the first problems, one of the things you want to remember when you're doing the integrations, you guys have to think of how you can separate this or rewrite it. When you're dealing with the fractions, the things that you want to look for is if the addition or subtraction is happening in the, hold on, right here, you need a plus sign. If the addition or subtraction is happening in the numerator, you can separate this into two different fractions. If the addition or subtraction is happening in the denominator, you cannot separate. You have to use substitution. So here we can separate this as two different problems, and then we'll be able to integrate them separately. No, it's fine. Okay, so if you hear me talking on this and you don't understand who I'm speaking with, I'm speaking to Alex. Okay, so now we can rewrite this a little further. Square root of x is the same thing as me saying x to the 1/2. Now on this second problem here, it's the same thing of x to the 1/2. But if you notice, you have, okay, pause real quick there, Alex. Right here, you guys have square root of x over square root of x, so these cancel. That's what I did here. So then you're just left with 1/3. That's where that's coming from. So therefore, we're integrating 1/3. I can bring up the x, so it becomes x to the negative 1/2 dx, plus I can integrate separately the 1/3 dx. Now, some of you don't like to rewrite it separately like that. That's fine. You don't have to. I'm just rewriting it, showing you that I'm integrating each piece separately. So now to integrate the first one, we need to increase the power by 1. Now it's power rule. Okay, so right here you have x to the negative 1/2. When I add a power, it's 2 over 2. That's what gives me that 1/2 that I'm dividing by, because then we divide by the new exponent. Now on the next one, 1/3, there's understood to be an x to the 0 there. So when you increase the power, it becomes 1 and you divide by the new power. So increase your power by 1, divide by the new power. So when I simplify the fractions, I get 2/3 x to the 1/2 plus 1/3 x plus c. And that's your integration for number 1. So whenever you have addition here at the top, if your addition or subtraction is happening in the numerator, you can actually separate these into two separate problems. Okay? Okay, go ahead. All right, for number 2, it deals with the trig. All right, for trig, there's different ways that you can look at the trig problems. You can either look at the trig problems as you might want to rewrite them as different trig ratios, or when you have something more complicating in the denominator, then you can use that as your u. So I chose in number 2 to use my more complicating function, which was in the denominator, as my u. Okay, so u is going to equal sine of 3t. So du equals 3 cosine 3t. So just to remind you how I got that, derivative of sine is cosine, and derivative of 3t is 3. So dx equals du over 3 cosine 3t. Now you can go back and plug all this in. I wrote. Okay. Okay, so we're going back and rewriting. You have cosine, 4 cosine 3t. I haven't done anything to that piece. Over u squared, because sine 3t became my u. Du over 3 cosine 3t. Don't forget the dt on the top one. I don't know. Maybe I forgot it right here. Did I forget it? Oh. Okay, so now at this point, we try canceling out. So what cancels out here? Okay, so now at this point, if you see when you substitute, what cancels? The cosine 3t's. So what's your coefficient that you're left with? 4 over 3. And then the u, what can we do with the u? No, you can put it there too. It can be inside or outside. So here now you can do u to the negative 2. Let's go ahead and bring it up already. And guys, remember, Alex is writing and I'm recording. So if you hear me talking, it's because I'm guiding Alex through it. U to the negative 2, because we're bringing it up. Du. Okay, so now we're going to start the power rule. So which means I have to do what? Add 1 and divide by my new exponent. So therefore my integration equals 2. And there should be a negative in front of the 4/3. Okay. All right, so we have negative 4/3 over u plus c, because we get u to the negative 1, so we brought down the u. Now you can go back and substitute what u is. And that would be my integration. Okay, next problem, number 3. Anytime you have a problem that has e, you're always going to make your u the exponent of e. Now, there were some questions earlier, and second block, you guys didn't get this clarification. But on the exponent part, that says negative 3j squared. All of it is over 2. J squared, and then all of that's over 2. So that's part of the exponent there, plus 6j. So stop real quick, Alex. Yeah, I have a paper that has the problem. All of this right here, this is your u. So this is all an exponent. Okay, that's the exponent from the u. But people were asking where's the 2, if it was, they were asking what the 2 was. Okay, so whenever we have an e, my u is always the exponent with the e. So my u here is negative 3j squared over 2 plus 6j. All right, so you already established what your u was. Now you need to take the derivative of u. And then we need to solve for dj. No. So du over negative 3j plus 6 is my du. So now, or my dj. So now I'm going to rewrite the problem with my u substitution in there. So we have negative 3j plus 6. That stays the same. Continue. Okay, so after we've substituted, now we can see what will cancel out. So here your negative 3j plus 6's cancel out. So we're left with the integration of e to the u du. And the integration of e is just e. So e to the u, no, we already took the integration. So the integration of e to the u is e to the u plus c, and then we can go back and substitute what u was standing for. Okay. So then we go ahead and we plug back in the u. And then plus c. And that would be our integration. All right, for number 4, you have trig. So again, when you have trig, you need to know the integration of all your trig functions. Otherwise, you're going to look at this and you're not going to know what to pick for what. Okay, so when you have these, if you automatically know there's an integration for that function and there's only one trig function or there's 2 trig functions and that is an integration, then you don't have to do all the rewriting and all of that. In this one, I have sine and cosine together, and there's no integration for sine cubed cosine. There's integration if it was sine separate and cosine, but these are together by multiplication. Yeah. So this one, we can rewrite it. It would be the same thing as me saying sine y to the 3rd power, all of that is cubed, times cosine y dy. So this one, I am going to have to pick something for my y, and my y would be the most inner function, which is my sine y. And when you're picking your u, you have to know what derivatives and integrations are. If I pick if I pick sine as my u, I have to already be thinking, well, the derivative of sine is cosine. That's going to work because I have a cosine there that I need to cancel out. Again, if you don't know the derivatives and the integrations, you're not going to know what to be picking and to see where it's going. So u equals sine y. The derivative of sine is cosine, and then we solve for dy, which is du over cosine y. So now let's come back and rewrite our integration with replacing u. So it's the integration of u cubed cosine y dy and then, I'm sorry, not dy, cosine, we're replacing the dy, sorry. So it'd be u cubed cosine y du over cosine y. So our whole point here is those cosine y's need to go away so that I have only one variable that I need to integrate. And so the y's do cancel. So I'm just integrating u cubed du. Now this is a basic power rule. So we add 1 and divide by our new exponent, which gives me 1/4 u to the 4th plus c. And then we rewrite it one more time because now we can put back what our u was. So it'd be 1/4 sine to the 4th y plus c. And that's my integration for number 4. All right. All right, so now number 5, it's another trig one. We have 3 cosecant squared of x over 4 dx. So you have to think, what could I possibly pick for u? You also should already know that there is an integration for cosecant squared. So if you already know there's an integration for cosecant squared, you wouldn't pick cosecant as your u. The other reason you wouldn't pick cosecant as your u is it's going to produce another trig function, and I don't have another trig function. I only have one trig function. Okay, so this whole problem can be rewritten as 3 cosecant squared of u. So our u is x over 4. Go ahead. Okay, so my u is going to be x over 4, which can be rewritten as 1/4 x. And then the derivative of that is 1/4. So 1/4 dx. Then I need to solve for dx. So dx equals 4 du. So, so when I come back and rewrite it here, I replace the x over 4 for u, and then I need to rewrite dx, which is 4 du. So now if it helps you, remove all the coefficients. So in this case, my coefficients are 3 and 4. And I have to multiply the two coefficients. So I'm pulling out the 3 and the 4. So I have cosecant squared u du. So 3 times 4 leaves me with 12 integration of cosecant squared u du. And the integration of cosecant squared is negative cotangent. Ready? Okay. So the integration of cosecant squared is cotangent. So negative cotangent, so the 12 becomes negative. My cosecant squared changed to cotangent u plus c. And now we can finally just go ahead and replace what u was. So that would equal negative 12 cotangent. My u is x over 4 plus c. All right. So looking at number 6, the difference between number 6 and number 1 is in number 1, the addition was happening in the numerator, so you can separate that. In number 6, the more complicated or addition subtraction on the rational function is happening in the denominator. You cannot separate that. That's the denominator, that's its whole. So then you have to use u substitution here. So first let's rewrite this integration. So it would be the integration of x squared over 1 minus x cubed to the 1/3 dx. So what's my most inner function? That is the more complicating part, is my 1 minus x cubed. So that's going to become my u. So du equals negative 3x squared dx. Solve for dx. So dx equals du over negative 3x squared. So go back now, rewrite your integration with what you have selected for your u substitution. So x squared over u to the 1/3 du over negative 3x squared. At this point, your other variable of your x's should cancel. You don't have to redo that. So the x squares cancel, so now I can rewrite the integration as negative 1/3, the integration of 1 over u to the 1/3 du. So again, all I did was factor out the coefficient. Again, some of you like to do that step, some of you don't. So it's up to you where you like to place that negative 1/3. Now I can bring up the u to the 1/3, which becomes u to the negative 1/3 du. Okay. All right, so now you have to do the power rule, which means you have to add 1. So the negative 1/3 is still there. U to the negative 1/3 plus 1, which would be plus 3 over 3. That new exponent becomes 2/3, which you have to divide by. So those of you that like to do the horseshoe, you can do the horseshoe. Those of you like to keep, change, flip, multiply by reciprocal, you all get the same answer. So that gives me negative 3 over 6 u to the 2/3 plus c. Then we can reduce and plug back in our u. So it gives me negative 1/2. U is, okay, u to the 2/3. Go ahead. That's fine. Yeah. All right, so Alex just pointed out something for me. You're going to see, if you look at the one that I wrote out, I didn't plug back in the U by mistake, sorry. So make sure that you go back and you plug in what U stood for. So here I should have negative 1/2. My U is 1 minus x cubed to the 2/3 plus C. So if you're looking at the written work that I have posted on class pages, make sure that you go back and you plug in that U. Okay? 7. All right, number 7 has 3 different pieces to it. You can integrate each piece separately. There are power rules except for the e to the negative 2x. For that one, you do have to do a little u substitution for that property. But again, on this one, you can do each one separately. Now, some of you, again, you're okay and you like to rewrite each one separately as separate integration. Some of you just start doing the properties right away. It's up to you if you feel like you need to rewrite this step or not. Okay, but we have to remember that you can integrate each piece individually. Okay, so for the first one, we can basically follow the power rule. X cubed, Okay, so just to do a little bit of rewriting, we have the integration of 4x cubed dx minus, I'm going to rewrite this one, bring up my x squared. So it's 2x to the negative 2, sorry, dx plus the integration of e to the negative 2x dx. All right, so add 1. Okay, hold on. Me and Alex are doing 2 different things. Hold on. Okay, so for the first 2 terms, we're going to follow our basic power rule. Reading it. Okay, so we add 1, which our new exponent is 4, so we divide by 4. Same thing on the next one, negative 2 plus 1 gives me a new exponent of negative 1, so I divide by negative 1. And then plus e to the u over negative 2 plus c. Now I'm going to explain real quickly on the side here where this is coming from, this part. This here, where is this coming from? From doing u substitution. Okay, so on the side we're going to do the u substitution to show where that's coming from. So my u would equal negative 2x. So du is negative 2x dx. I'm sorry, negative 2 dx. So then du over negative 2 equals dx. And so that's where this negative 2 right here is coming from over here. Because if I rewrite this, I would get e to the u, and the integration of e to the u is e to the u. And then dx we're replacing with du over negative 2. Okay, so you have e to the u du over negative 2. So here, that's where this is coming from, because the integration of e to the u is e to the u, and the coefficient is negative 1/2. That's where that negative 2 is coming from. So now let's clean it all up and write out our full answer. So 4 over 4 reduces, so I'm just left with x to the 4th. Negative divided by negative turns to positive, so I'm left with 2x to the negative 1st. Okay. Plus c. And then you can rewrite a little further, that x to the negative 1, you could bring it down. So it's 2 over x. And then on the e, we can replace what u was. So it'd be 1/2 e to the negative 2x plus c. And that's our integration. Yeah, let's just correct it. Hold on, guys. We're going to correct right here. This and this, they should be minus because it was a -2, so it's -1/2, -1/2. Guys, I'm only going to do 1 through 7 on here that deals with the integration part because it takes a lot of time. This is already a 25-minute video. I have already done all the show work and I posted it online on class pages. So for the other problems, go ahead, look at the notes that are written. If you have questions, there's going to be tutorials tomorrow morning at 8 o'clock so I can help answer those. All right? And so say thank you to Alex for helping me so I didn't have to do everything double. Remember, Miss Gomez drinks a white chocolate mocha from Starbucks. I like Chick-fil-A biscuits as well. See you tomorrow, guys.